Marilyn is a PhD candidate at the Information School at the University of Washington. Her studies are focusing on data visualization, which fits quite well with this breakout session. So I will turn things over.
Okay, visualizing data. I've designed this talk to be very pragmatic. I always like being able to walk away from the talk with sort of things I can actually do next, so that's my intent here. I'm going to cover these 4 topics. Why do visuals work? When do visuals work? What makes visuals effective, and what makes an effective visualizer? And I've put together a website with some links to resources I'll be talking about. I'm going to pull this up again at the end of the talk, so you'll have it, but I just wanted to let you know in advance that that would be available for you. Okay, so first of all, why do visuals work? This section is slightly academic, but I find it helpful to have an orientation to visualization that is sort of just a somewhat theoretical orientation. So we have a powerful set of resources in our visual system, but of course they're designed to process information like this. And it's interesting to think about, why do they work, the process? Why do those resources apply effectively to information like this? So first of all, if you just think about what our visual system has to do for us, it helps us navigate, it helps us move through space without bumping into things. It helps us manipulate or interact with the world and get feedback from it so we can see the effects of our interaction. It helps us identify things, that's a tree. And it helps us anticipate in terms of we have expectations about what's going to happen in the world based upon what we see. So none of these particularly apply to data visualizations. So we need to step back and say, okay, what is it the visual system needs to do in order to enable us to navigate effectively? Well, it needs to enable us to perceive spatial relationships, and our visual system is extremely good at that. Immediately we see what's where and how it relates to ourselves and other things in the environment. In order to manipulate, we need rapid and simultaneous feedback. We need to immediately see the impacts of what we've done. No time delay, and it needs to be simultaneous. We can't just see what happens here and then what happens here. It needs to all come to us simultaneously. In order to be able to identify things, so for those of you who have studied the visual system, it's fascinating. We're not like a camera that just records what's out there. Our brain is actively processing information and building a sense of the world. And our visual system allows us to discern patterns and lines and colors, and we use that information then to identify things. And then in terms of anticipation, we have an enormous database that we can access at low cognitive cost. Immediately I see that, and I know that's a ferry boat. You don't know that because you're not looking at it. And so we can apply those qualities to data visualization. So spatial relationships are very important in most data visualizations. We immediately see how things are related to each other. It's rapid and simultaneous. Of course, that's one of the big powerful things about visualizations as opposed to text, which is sequential, linear. You have to process it through time. With a data visualization, we get it all coming at us at once, and we can see it all at once. We're able to discern pattern, lines, and color, and we use that in our data visualizations. And then we have an enormous knowledge base. We actually use some of our understanding of how the real world works in order to interpret data visualizations. Okay, so then the caveat is that visuals don't necessarily work. They work when we leverage our visual system effectively. So here's an example. This is, for those of you not from this area, this outline is King County, which is the county we're in right now. And all of these data points are incorporated in Townsend City within King County. And they've been encoded by size. So here the encoding is by shape. So different sizes of, so for example, Seattle is the only very large, I think it's over 600,000 data point there. Here they've been encoded by size, and what you can immediately perceive, even though all of the information is there, this one is clearly much more effective. So the idea that just because it's visual, it's not necessarily effectively leveraging our visual system. So when do visuals work? So this is a mnemonic that I've come up with. It's inspired by one of the resource books I'll point you to. There are some types of information that tend to be visualizable. And I use my hand to remember them. I think of hitchhiking for thumb, spatial information, so location information. Numbers, numeric information tends to be very visualizable. Third finger, I think of waving, appearance information, clearly, what something looks like. Ring finger, relationship information, and little finger, time is the other one. So I'm going to go through those briefly and consider why those are very visualizable. So timelines, they're actually tend to be only slightly visual, mostly text, but it's all about spatial. So it's interesting, again, we have our visual systems are very good at processing spatial information, and it's not difficult for us to translate time into space, which is, I mean, it's an abstract translation, but it's easy for us to do. So sequence and relative spacing is easy for us to understand as sequence and time and relative distance between time events. So time visualizations are all about spatial relationship visualizations, so things like organizational charts or network diagram are also essentially spatial in nature. And again, it's the translation of an abstract relationship into a physical spatial relationship, and our brains have no trouble doing that. Appearance, obviously, if you need to convey information about what something looks like, the best way to do it is with a visual, it may be a photo. I use this representation because this does something that I like to do, which is to use appearance to convey data concepts. So the data is conveyed in the numbers, but the little icons help us understand, anticipate what type of reference they're referring to, what type of physical object they're referring to. Numbers, this one relies pretty much on that database we have. So the fact that when I look out there and I see a small pile of something or a large pile of something, I know that that means a small number of something and a large number of something, so we can directly translate it into large things on in our visual system. This one actually is equating height with numbers, and again, things that are higher or taller tend to be bigger. Our sense of gravity is that it takes more to move away from gravity. So it's intuitively natural for us to translate height or size to number values. And then finally, maps. Maps are all, of course, about spatial information. So since we're good at spatial information, they work well. This one, of course, also has a number component. It's a data map. So it's using size as well as spatial relationships. Okay, so again, there's 5 types of information that tend to be visualizable. And what I do is if I'm faced with information that I want to convey visually, I search for visual potential, and I literally think about those 5 things. I'm going to do a little pause to encourage you to think about the data you work with. What sort of visual potential is there in that data? Terribly long pause. We'll move on to the next section. So what makes visuals effective? There are, obviously, this is a rich area. I'm going to focus on 3 that I think are quite key: encoding, layering, visual hierarchy, and context. So the first one, encoding. So the essence of a data visualization is that you take an attribute of your data and you systematically translate it into a visual attribute. So I'll explain what that means a little more. This is a simple data visualization that I'm going to use as an example throughout this talk. It's showing commute distances to the University of Washington by these 3 groups: students, staff, and faculty. And then the distances are chunked into less than 1 mile, 1 to 5 miles, 6 to 10 miles, type of 11 to 20 miles, and more than 20 miles. So what are the encodings here? Color encodes category. And that's a fairly intuitive encoding. If you see different things that are different colors out in the world, they tend to be different types of things. So that's a useful intuitive coding. Height, again, the bigger things are, the more they are typically. Position, so this is essentially a direct encoding. So distance from the university is the same, in this case, as distance along the x-axis. So there I have those 3 encodings. And of course, with almost any given data set, you have options. You need to choose which encoding is going to be most effective, and the primary thing is which is going to be most intuitive, which mapping is going to be most intuitive. But also different encodings will tend to emphasize different aspects of the data, so you need to think about what you're trying to convey with the data. So for example, the same data, in this case, I've encoded color, or rather value, so brightness of the same color, to indicate distance. And that's a little less intuitive than distance along the x-axis, but it's still, again, our real world experience is that if there's more color, there's more intensity. If there's less color, there's less intensity. So that mapping of less to lighter is fairly intuitive. And I get a different representation that has a different emphasis. Here I can kind of see the profiles of what student, staff, and faculty commute distances look like, in contrast to the previous one that gave me a different sense. This one helps me compare within a commute distance more effectively. Oops. Okay, what I did here was, since these buckets of commute distances differ, I wanted to represent that a little more accurately. So this is just 1 mile, this is 5 miles, this is 5 miles, this is a 10-mile increment. So in a way, this is it is a more intuitive, more accurate encoding, but I've also run a risk here because this is not what we expect to see. So of course, you're always having to incorporate audience expectations, and when you violate them, they're going to have to do a little more work. So you have to decide whether that's worth it. Here's another encoding where I've double encoded. So category, color means category, but also spatial position, in this case, means category. And again, slightly different impression. It's easier for me to look at each category of commuters, but it's a little harder to compare between categories. And then I threw up this one. This is actually a visual I created and was used in a report. It's similar data. It's about commute distance. But here what I've done is I've encoded number of people by number of people. Though in this case, each little person represents 1% of the population. And I showed and then I've encoded category by value, by brightness. So I just threw that up just to remind us that there are other alternative encodings out there than the ones we're typically accustomed to seeing. And it's good to explore the option. Okay, now what I'm going to do is I'm going to show you a number of New York Times infographics. They do amazing stuff, so I always go to the New York Times graphics for inspiration. So this first one, this is a data graphic showing home values over time. And so again, they're encoding. This is, of course, a fairly common data graphic style. This is a time series. And value of home is encoded by height on the y-axis. And then time is encoded linearly on the x-axis. This is a display of different types of cancer and incidence in a given year and deaths in a given year. And then it's split up women and men. So you can see there's encoding by position, left and right. There's encoding by color, the greenish colors versus the bluish colors. There's encoding, of course, the major encoding is by bar length, and that's the number of cases. And then there's this difference between a dark value and a light value. So all those different encodings are happening. This one is meat consumption. So again, it's the standard time series. Height means how much consumption. Time is on the x-axis. And then we have color to distinguish the different types of animals that have been eaten. And then finally, this is showing the evacuation zones around the nuclear plant in Japan. And there are a lot of encodings happening here. We have color encodings for the different evacuation zones. We have value encoding for population density. We have bar length for radiation exposure, all happening simultaneously in the same graphic. Okay, so again, a little pause. Thinking about the data you work with and what types of encodings might be intuitive for that data. Okay, the next thing I'm going to talk about in terms of what makes visuals effective is the concepts of layering and visual hierarchy. And this one is valuable because there's always a tension when you're creating a data visualization between the complexity of the visualization and the complexity of the information. Most really, really simple, informationally simple data visualizations are not very interesting. Usually you need to create some complexity, but you want the viewer to have a sense of this is simple to look at. And layering and visual hierarchy are an important way to achieve that. So what are they? So again, the way our visual system works, when different things have different visual attributes, our visual system can easily pull them apart. So here, we have a bunch of things that are all the same color and the same thickness, and so they compete with each other visually. But if we change the thickness and the color, we have much less competition happening. And then as soon as you do that, you start creating visual hierarchy, which refers to which things are more salient, which things pop out at you, and which things are less salient, which are sort of in the background. So I can emphasize that here. So I've created both layering and visual hierarchy. And if you think about how our visual systems work and how camouflage works, basically camouflage animals, they're taking advantage of, they're trying to minimize the visual cues that our visual system uses to distinguish objects in the environment. We want to do the opposite. So here's, again, that same data set that I showed before, and this is sort of the default view that you get in Excel. And I'm just going to show you a couple of things that I typically do with an Excel graphic. So it starts out with, there's some visual hierarchy going on, and the title is much more visually salient, and that's appropriate. It helps you orient you to what the visual is about. But then there's a lot of elements here that are about the same visual hierarchy. The grid lines and the axis labels and the key labels. I typically immediately back off the grid. Actually, it's still there. I don't think it's even visible to you. But there aren't that many situations where you need that level of precision, and so that just reduces the amount of visual hierarchy. I also generally remove the axis lines, because usually you have enough visual cues to basically recreate those in your mind. And then I typically tone down the axis labels as well. You know where to look for those. You know they're going to be there. They need to be legible, of course, but they generally don't need to draw your attention. And so I'd rather draw attention to the things that help orient to the topic of the visual. And then in this case, say I want to emphasize staff. I can make those data points more salient and make the others a little less salient to create a little visual hierarchy there. Okay, how the pros do it. So if you just look at this and think, what grabs your attention initially? Basically, I think you'll agree the things that jump out are first the main data line, which is appropriate, and then the title, which again is also appropriate. And then other things are more subtle and have less visual impact, like the bars that indicate different time periods and the text. So even though there's a lot of information here, it's easy to look at, and it's easy to have your attention drawn to the thing that needs to be drawn first, and then you can start exploring more. This one has less visual hierarchy in some respects, but still you certainly see the title, even though it's not in the standard upper left-hand corner. They managed to make that work anyway. In a way, we've got these different things up here at the top. We have the labels that explain the difference between the pale and dark bars. We have the data values, and then we have the men-women labels. There's not a lot of visual hierarchy going on there, but they're clearly distinguishable. They're all slightly different, so so they're layered in that sense. If they were exactly the same typeface, then they might compete with each other a little bit. And here there's a lot of layering going on. Again, and there's a lot of information, but I think your attention generally is drawn to the central point first. That's the most salient thing. The title's a little subtle, but it's definitely it's where you expect it, in the upper left-hand corner. And then maps are a great place to see layering. It's amazing how much can be on a map and still allow you to look for the things you're looking for, whether it's the highways or the cities or whatever. So we've got all of this information about population density, and yet it's not competing with the labels, for example. And these these zones with the red lines, you know, if they were black, they would compete quite heavily with the text, but they're not. So it's all very well done. Okay, so that's layering and visual hierarchy. Again, the goal is to create a visual impression that is easy to process, that's not creating a lot of competition, so the viewer knows where to look. Okay, and thirdly, context is huge in making a visual effective, and this actually is a little more about content, but it's relevant. I mean, the essence of a visual, the fact that you can put more than one information in the same place is a strength of visuals, and it also contributes to the story. Essentially creates a story out of the data. So to add context, the way I think about it, I either want to add more of the same type of data to tell more of a story, or add related but different types of data. So I'll explain what I mean by that. So say we have this one central bit of information that we're interested in, the fact that 16% of UW staff, I'm using the word UW, University of Washington, staff commute more than 20 miles. There's no context there, so it's hard to get a sense of how significant that is. So I can provide context by adding similar information, more commute distance information for that same population. Or I can add context by providing, again, similar information, more commute information for different categories. I can put it all together, and again, it just creates a richer story. This data point now means a lot more because I have more context to put it in. Or I can add other types of information. So what I've done here is, here's my commute distance information, here's my mode split. So these are how these different categories of individuals commute: transit, drive alone, carpool, bicycle, other modes, walk. So again, this is a different type of information that creates more context for my central point. Here's another one. Here I'm trying to show what that commute distance means. So I have a map of Seattle and Puget Sound, and I have the zones that correspond to those commute distances. So again, it immediately creates more of the story. It creates more context for that central data point. Okay, so now let's look at the New York Times graphics. So again, we have our central topic, and here we have these historical periods that help create a story help us understand meaning. Why did the home prices go up when they did? Here, essentially, this one, there's a lot of the same type of information, which is cancer occurrence, but I have a lot of comparison factors. So I can compare men versus women. I can compare across types of cancer. I can compare deaths to occurrence. So all of that creates context. So any single data point now has a lot more meaning than it would if I showed it by itself. Again, another time representation where they've indicated historical periods to give context for what was happening. They also have these little call-outs where they refer to things like the first McDonald's restaurant opens, and that had an impact on beef consumption. And then, of course, just each of these data lines gives context to the others. If you only saw one, you might wonder, well, did meat consumption rise in the same way for all types of meat? But you can see that that's not the case at all. And then here, there's lots of different types of information, all providing context for each other. So we have the evacuation zone, but it's very interesting to see the context of radiation exposure and how that relates to those evacuation zones. Okay, so again, summarizing, adding context by providing more of the same kind of data, but for a different group or a different category, or adding some different but related information. So again, I'll pause for a mental moment of rest or to think about your own data and what sort of context you can provide for it. Next, what makes an effective visualizer? So that's, of course, a very big question, but I'll summarize it as knowing rules, tools, exposure, experience, and getting feedback. So I'll summarize those. So rules, Design principles, perception principles. There are some excellent books out there. These, as again, I've linked to them in the website I created for this. And my experience with rules is, you hear a rule and it sounds very simple, but actually implement it is a much more complicated thing. And I think you expose yourself to the rules and then you just keep experiencing them and they make more sense and it gets easier to figure out how to incorporate them. Tools, so I generally am creating data graphics from scratch. There are a lot of tools out there that will sort of create graphics for you. For what it's worth, the tools I use most are Excel for manipulating data, then I often pull it into Illustrator, Flash if I want interactivity. All of these, the challenge of course is all of these have a learning curve associated with them. I'm going to talk about some tricks that I personally like to use to improve my skills in a moment. Exposure. I try to expose myself to data graphics all the time. I subscribe to a number of blogs that send me emails almost daily that then point out excellent graphics people have done. There's a link to, this is my favorite, there's a link to that blog in the website. And then almost always when I'm about to create a data graphic, the first thing I do is go to Google Images and try to see what other people have done. And partly for inspiration, but also just to keep exposing myself to different strategies people have come up with. Okay, my favorite learning strategies are to recreate and emulate. And so what I mean by that is I'll make an exercise for myself where I'll take typically a New York Times graphic and I'll try to recreate it with my tools. So in this case, here's a little bit of a screenshot from the graphic we were looking at. And I thought, well, can I do that in Excel? And so I started with a standard bar chart. I knew I could make the bars overlap. But I didn't know how to make one thicker than the other because that's not a separate attribute that you can change until I came up with the idea of just giving one a thick line around it. So it's a fun thing to do and it's relevant because if you just sit down with a tool, there are so many capabilities that tool has that it's hard to know where to start, but if you start with an existing visual, you know that that's a meaningful thing to try to achieve because somebody else has achieved it for their meaningful visual. And then emulate. So again, this is the sort of default view that you get from Excel. What I've done here is, so I went to a number of annual reports, and I looked at the style of the annual report, and then I tried to apply that style to my data graphic. So that exercised my ability to figure out how to change formatting in Excel. And it also, to some extent more importantly, it helps attune me to what visual elements is that report using to create a certain tone and a certain effective type of display. So here's a page from McDonald's and a report. I tried to emulate that. I've got the pickles, the shiny. Here's one from IKEA. Looking for the font, looking for here. I added the data labels because they had done that. So it's fun and it's a way to exercise your ability to sort of see what's going on and what choices they've made to make their presentation have a certain look and be effective in a certain way. And then finally, I consider this absolutely the most valuable way to improve your visualization skills, which is to ask other people how they're responding to it. Really what you want to do is see your visual through another person's eyes. And this is something that nobody, no matter how skilled they are, nobody graduates to the point where they can anticipate what their visual is going to look at through another person's eyes. It's always, it's like getting someone to do your work for you. It's like magic. And I have these two bubbles because they represent sort of the two types of information I really want to get. If I just show a visual to someone and say, well, what do you think? There are two things that happen that are not very useful. One is that they'll tend to be reluctant to be critical, so I don't get the candid feedback I really need. And the other is I'll often get sort of superficial things like I don't really like the color scheme or something. Whereas what I really want to know is whether the information is getting in their head. And so strategies to address those are to make two versions, because then they can tell you they don't like something by saying, I like it better in this other version. And then by trying to ask, well, what are you learning from this visual? And that's a way of seeing how the information is going into their head, rather than having them focus on something that seems more obvious to them, which is the type of the color scheme. Okay, so to summarize, rules and tools are sort of the baseline. The more you know them, the more you can move forward, but they don't stand on their own. Exposure and experience helps you learn both the rules and the tools, and then feedback I consider the real clincher that helps move toward being a more effective visualizer. So, in overall summary, we looked at why do visuals work, and that was that orientation to what our visual system is designed for, and why we can use those skills and apply them to something it's not designed for. When do visuals work? That was that 5 types of information that tend to be effectively visualizable. What makes visualizations effective, or visuals effective? And again, I focused on 3 key points: encoding, using an encoding, a translation that is fairly intuitive, layering and visual hierarchy to help reduce the visual complexity and help walk the viewer through your visual, and context, providing other data to create a story around your visual, around your data. And then what makes an effective visualizer, that's the one I just covered: rules, tools, experience, exposure, and feedback. And then again, here's the URL for the web page I put together. There's a link to this PowerPoint deck that's of interest. These are all links to more information about those books. This is that blog that I really like. I actually have a copy of the Excel file where I emulated IKEA and McDonald's, if that's of interest. And then I have a series of tutorial videos that I've created for other purposes that if you're interested, you might want to look at. They tend to focus on Excel and Illustrator, but I also have some where I walk through the process I took of going from a raw set of data and coming up with a visualization that was effective. So we have lots of time left. Are there any questions or comments? I realize there's probably a lot of expertise in this room. Anybody want to make a point about something I didn't?
Yeah, sorry, I just have one quick. The E is missing and the second E is missing in your name.
Yes.
Is that
My
correct?
last name is too long, so
Okay.
I had to do, but yeah, that's accurate. Yeah. I cut and pasted that, so I know that works.
I'd like to get some thoughts on sharing visuals. I think a lot of us struggle with, do we print things out, and do we, especially if we don't have like a fancy color printer at our disposal, or if we're going to be sharing it electronically, maybe we don't have the resources to kind of put things on the web, or which one is more powerful, do you think, better?
So sharing in terms of literally letting each other use them, or just to have other people look at them?
If you're making a graph for somebody in your workplace who's going to be using it
Yeah.
for their work to inform decisions.
Right. Yeah. Well, I guess one thing that drives that is if you design something for print, it will have a different impact in printed form. I guess it depends on the person looking at it as well. If there's someone who doesn't like to look at things on the screen. Yeah, if you don't, yeah, it's nice. I have access to this website where I just look things up. Yeah,
I was
Joel,
going
do you
to
have a
say, one of
comment?
the things that I do with our reports is I print the PDF, look at it on the screen. I print it with color printer to see how it would look, and I also print it to black and white to see if my colors start to look the same. If I print to black and white, and if they do look the same, and I can't differentiate, like it could be obvious where I'm using like gray and yellow on screen or in color, but then when I print it out, the gray and the yellow look exactly the same in black and white, and like especially if I'm using like a stack bar or something, to differentiate between gifts and grants or something like that. If it blends together on the black and white, then I go, crap, I gotta pick different colors.
Right.
Because I try and it's like same thing with web design. You almost kind of have to design to the lowest denominator in a way, in that case, to help with those things. It
Yeah,
looks great
there's-
in color, but then you print it out in black and white and it all comes out in one color.
There's a line that is get it right in black and white, which is that is always a good test for your visual. It also means if you have, well, you will have viewers with color blindness issue. The major one is red-green colorblind. So you want to avoid that anyway, but if it works in black and white, then it'll work for someone who's red-green colorblind as well. Mhm.
So I know you want to make your visual very rich and convey a lot of information, but is there a point in time, and I'm asking because I know you've done a lot of research and actually in how we think about things, where there's too much information? I mean, if you have to look at a visual for 5 minutes to figure it out, it's for 1 minute, what's the kind of guideline there?
Yeah, well, it depends on the context. If you're showing, if you're doing a presentation where people only have a short time to look at it, of course really have to have basically one point. Also, I mean, in that context, you're there to narrate, which is huge. You can create a story even when there's no story in the data. Like the New York Times graphics, they expect people to spend time processing them. I mean, in a way, again, I look at them because their data graphics, it's almost always the case that you could glance at it and walk away with the important point. But if you spend the time, you can get more out of it. So they have the skill to enable you to get the best of both worlds, but that's really hard to do. So yeah, if you like, yeah, reports, you can assume that people are going to be scanning them and they're going to want to spend as little time as possible. So the main thing is you can get something out of a glance. But I don't think you have to get everything out of a glance. And if the glance pulls people in and helps them invest more time in it, and then they can start noticing the subtler details that add to the richness of the story. So the ideal is to get it. I guess only when you really don't give your audience a chance to spend more time with it. Like I showed you all those data visualizations, and I didn't give you a chance to really process them because I was narrating and hopefully getting you the most important information across quickly. But to some degree, that was undesirable because I didn't give you a chance.
Yeah, I'm interested in interactive visualization. So I'm getting ready to do a test deployment of Tableau.
Uh-huh.
And I'm trying to move some of my old school non-digital people who are totally into it has to be in Excel, look this way. I'm trying to come up with dashboards that it's like, hey, you can have it, we'll still email the PDF to you if you want, but here's a desktop. You can actually click on the data point, right mouse click, say view the data. You can do the slider and do the what if. Any kind of insights in how you move somebody from being a printed format to an interactor on a dashboard with KPIs.
Yeah. So I mean, the whole thing about interaction. It's sort of a two-edged thing where you can wow people with interaction and you can overwhelm them with interaction. And you can enable, particularly when you have, actually, there's a great example which I'll just describe to you. There's a TED Talk, if you're familiar with the TED Talks, the inspiring talks that you can find on YouTube or on the web. There's one by Hans Rosling, and it's about, he's presenting information about, it's global information.
Yeah, he has a good one on mortality. And he has a link you can actually download and play with.
So exactly, yeah, and so that's the thing. You watch there are several of his presentations. I think the first one is still kind of the most amazing one, where he shows how the world has changed from being a world where where it's split into developing world and undeveloped world to a world where there's a gradation kind of on all aspects of life measures. But he does this great show that is very inspiring, and he conveys the information very effectively. And then if you actually go to the site, you have all these options. You can choose different data, and you can interact, and you can move sliders. It's very hard to come up with an interesting story like what he's done, because there's almost too much, and he gives all the context for it. So I think that's an example where I think a lot of people would just get frustrated unless they have a lot of persistence and really are interested in the data. But back to the basic question, I mean, I guess I would start with having a visual that doesn't require interaction, where you can look at it and you can get the information you want. But if you happen to move your mouse over it, something interesting happens, like it pulls up a bubble with more information about a data point. So it's not, what you don't want is to have someone feel stupid. That's going to turn them off. Nobody likes to feel stupid. And if there's someone who is a little defensive about the fact that they really are just comfortable with a printed version and feel a little overwhelmed, they always have a negative experience with the interactive version. So that's the main thing, is to make it so the interactive version works without interaction. And if you happen to interact with it, it does something that is interesting, and you can immediately see the value. Not that it's easy to achieve that, but that's what I do.
So basically, you always have to start simple. Transition. My organization is transitioning from basically written electronic formats everywhere to something that's a more unified electronic format. Reporting has been difficult because we're going from I just print this off and do this to, this is displayed on my screen, this is here, do this, and then taking the next step, which is going from a list of Excels, like you said, to something visual. That's, you almost have to start simple. Start with a very simple graphic and maybe add one thing to it, and then get that going in the organization, then take the next step, add something a little more, and just kind of piecemeal it. And that takes time, because that's kind of the opposite of what a lot of executives want. I'm going to wow, I want to do this, but that's, but if you wow, and then you start wowing, trying to wow everybody just gets overloaded. So we just have to do little pieces.
And the thing, when you start showing people your visuals, and I assume many of you already had this experience, it can get frustrating because you think you have something that is so clear, and you show it to them, and you're kind of like, I thought you were smarter than that. But the reality is it's hard to process visual information. So that's sort of the humility, is you have to realize that it's hard to do, and starting simple is essential because you will miss a lot of your audience. It's not that they're stupid, it's just that it's hard to process. And it's hard to create effective visuals. I mean, I'm so awed by the New York Times graphics people because they make something really, really hard look easy.
Considering the number of new devices out there, what are some tips or pitfalls or any advice that you can give regarding visualization and other sorts of devices?
Yeah, well, the main one is, sadly, the Flash doesn't work on iPads. And there really is no equivalent. I mean, there's kind of the sense that we need to move away from Flash, but there really isn't a good alternative to Flash. And it's frustrating because you can do really cool things with Flash. But it's evolving, and Adobe is trying to come up with new strategies for being able to do the same sorts of things. It's just not nearly there yet. I guess most devices, PDF is kind of a nice generic platform that most devices can process.
I guess there must be some sort of change in the way we can conceive of our visualizations because of this limitations of size and
Yeah,
some cases.
I mean that's certainly, like with any web development, ideally you think about how's this going to look on an iPhone, how's it going to look on an enormous monitor, how's it going to look on an iPad. Yeah. I don't have any easy answers to that, but it's good to think about.
Yeah, I'm interested in the storytelling aspect of this. That I said earlier that I take reports to the UW Board of Regents, and they're heavily weighted toward retailers. So they're always thinking about growth, and they're always thinking about kind of a market in which you have all retained customers and then you add customers. That's not our context. And so I'm always trying to dissuade them from just jumping to this kind of growth model.
Right.
And then I also have another problem, which is sort of political. When they say to me, to what do you attribute your success? It's not appropriate for me to say it's great staff work. What I have to say is it's generous donors and outstanding leadership by you guys, right? So the storytelling, your presentation really objectifies the visualization of data, but the story you're trying to influence somebody's thinking
Right.
with your story.
Right.
Can you talk a little bit more about that?
Yeah, okay, so and I realize I'm not repeating questions, but it kind of sounds like people are hearing that we're all talking about sort of the orientation toward the marketing perspective, and that success is defined by numbers and dollars, and that creating a story that appeals to people's values. I realize I'm kind of going, departing a little bit by what you're saying. I mean, so an aspect of visuals that I didn't talk about is that they affect our emotions. I mean, again, our visual system is designed for us to interact with the world, and the world has personal implications for us always, with emotional implications. I doubt I'll be able to come up with a profound response to your question, but there certainly is the idea of tone. I mean, you could see those 3 different versions I had of the graphic that was trying to emulate McDonald's and IKEA and New York Times. That they gave you a different sort of emotional response, where the one seemed serious and one seemed kind of fun and playful. That's part of the storytelling. I mean, I guess I'm thinking about the New York Times graphics. In a way, I mean, that they're a little bit. There's actually a couple of articles I've read that talk about the rhetoric of visuals, and it's called Cruel Pies, actually, because it's talking about, like the cancer data. That has a real emotional component if it's something that's happening in your life. And it's a little bit, it's squeezed out in that data graphic. And whether that's inappropriate, or whether you should do things to acknowledge the sensitivity of the information, I mean, that's, I guess, for everyone to decide. Those are my comments at your question. Anybody else have some thoughts?
My question is actually somewhat related. I struggle sometimes where I have a data set, and when I know what the main point is or what the takeaway should be for the rest of my team, great, easy to visualize. You sometimes asked to demonstrate visually a data set where you don't quite know what the main point is. You need to interpret as you're presenting, and I guess what we were trying to figure out what kind of visualization is appropriate.
Yeah, so actually I find myself almost always in that position where I have some data and I want to create a useful information visualization, and I don't know the story. I mean, so I explore the data and try to find the story that's in it so I can come up with a central point. And yeah, that was a point I didn't make, which is an effective visualization will have a central point, will have a central story you're trying to tell, because if it doesn't, the viewer will feel at sea. But yeah, when you're in a situation where there really isn't a central point, I mean, I think you have to try to identify one. If there isn't a story, I mean, actually the commute data I showed you, in a way I was disappointed it wasn't a great graphic, or a great data set, because I haven't figured out what the really interesting story is there. So, I mean, there's this thing about more staff are commuting from long distances. And if I'm interested in, so I'm very involved with sustainability efforts on campus. So with commuting, we're looking at, the environmental impact of different commuting modes, and thinking, why is it that so many staff live far away? And there are various things like they're less likely than faculty, for instance, to have moved to Seattle in order to work at the U. So they're less likely to have moved close to the university for that purpose. You know, the chances are that it's a dual income family, and so the other person works at a job that's in a different location. So there are lots of stories potentially in that data, but I won't be able to create a very compelling data visualization until I can identify at least one story that then can draw people into the data and get them interested in, maybe then they can see other stories that are related.
So sometimes the data doesn't tell the story that people want to be told. But, you know, without like, obviously just making it up. How would you maybe minimize differences or, you know, like reverse your technique, I guess use your powers for evil?
Oh, yeah. I mean, there are lots of ways to lie with visuals. I mean, so like I've created a bunch of visuals of sustainability issues at the university, and a lot of those are positive stories, but some of them are you know, well, not much has changed. So like you look at electricity consumption at the university, and it has gone slowly up. But if I look at campus population and building space, those have gone up as well. So again, I put those together and it tells a story, and it maybe says, you know, okay, we're maybe not doing so bad. I mean, the other thing is you can have the visual tell an obvious story, but have some text that tries to sort of be gentle. I guess it depends on what you're motivated. If you really feel like, okay, this is the reality, I want people to be able to see the reality, but I want to soften the blow so that they'll be willing to absorb it rather than wanting to simply reject it, then I think there are strategies to help, either with text or other data, to help soften the blow. But still, you know, it's sitting there in front of you. This is the reality. We might as well face it. And I would rather not be in the game of trying to make data look like something that it's not. But you certainly can. You can shorten your, you know, cut off some of the data that didn't fit quite right and it was earlier on, so I'll ignore that. Or choose a different level of granularity that kind of makes, you know, the little intermittent peaks disappear. There are all sorts of things you can do that, depending on how you look at it, either provide a more or less accurate picture of what's there.
Here's from an academic standpoint, New York Times graphics often incorporate the text into the graphic.
Yeah.
And just get your perspective on how useful that is versus a standalone graphic within the context of a broader article.
Yeah, so that's actually something I've thought about a lot, because I think that's a very effective part of what they're doing. They incorporate annotations that help you interpret the graphic, that help tell you the story they want you to see, which I think is very useful, and give you some background that's not actually in the visual. My current research is actually looking at scientists and how they learn to create visuals, and visuals are incredibly important in science. But there are a lot of conventions, and certainly the idea of putting text on the graphic is not conventional practice in science. And probably wouldn't be allowed. But yeah, my personal take on it, okay, so there's the other potential perspective, which is that you're biasing the interpretation by telling your story. But that's essentially always the case. I mean, you know, as we've seen, there's not one way to create a visual. So when you make your decisions about encodings and about everything, you are biasing the interpretation of the data. It's not like there's ever a truly neutral interpretation. So I think it's to provide text to help bias the interpretation and hopefully let people say, I disagree with that, and read it differently. We're all done. Hey, thanks very much.